Assalamualaikum warahmatullahi wabarakatuh and good day to all students. I think we last lecture we stopped at this slide about bus stop and now this bus terminal. Okay, design of street buses terminal and transfer to involve additional considerations. Not only estimate passenger service times of bus, but also clear understanding how each bus route will operate. So the loading area requirement and sizing of facilities may establish for following consideration. First, we look at the schedule and recovery times as a factor, driver relief times, and layover to meet schedule departure times. Okay, for loading area, space or designs requirements, first we should look into the specific type of transit operations, fare collection practices, bus door configurations, passenger arrival patterns, amount of baggage, driver layover or recovery times, terminal design, loading area configuration. This kind of the typical example. What the loading area for bus services design. Okay, so now we look at the layout for on-bus street stop. On-street bus stop are typically located curbside in one of the three locations. So we might have a near side spot or types when the bus stop immediately before an intersection. So for the near side, we consider the bus stop located before an intersection. The next, we have a far side when the bus stop immediately after an intersection. So this one before, this one is after intersection. Okay, the third types is mid block when the bus stop in the middle of block between intersection. So to have a clear understanding, I will share this kind of illustrations. So the first one under near side types. This one the mid block between the intersection, and the third category of the type is far side after the intersection. Okay, the location of bus stop influence capacity, particularly when passenger vehicle are allowed to make a left turn from the curb lane. If you look at this scenario, okay, of course, when a vehicle to make a left turn, of course, is affected if near side a type compared to this type or this type. Okay, fast side stop have the least effect on capacity. Buses are allowed to adjacent lane to avoid left turn queues, followed by mid block stop and near stop time. Okay, loading area requirements. Okay, the key factor influencing the numbers of loading area are required. First, bus volume, the number of bus schedule to use a bus stop during our direct effect the number of buses that may need the use the stop. So it's mean if we supply or we have frequent number of bus, it may have affected the time to taken need to be stopped at each bus stop locations. Okay, probably of queue formations. Failure rates, the probability what queues bus will form, is an important design factors as well. Okay, loading area design. Sawtooth is a typical type of the design for area, loading area. And drive-through loading are very effective since bus move in and out of the loading area independently of the other buses. Okay, next, traffic signal timing. The amount of green signal times provided to street that buses operate on affected maximum number of buses that potentially can arrive. So we can avoid that the buses will have a route near to the or crossing any signalized intersections. Okay, that's why we affect the number of loading area. The amount of rate signal time influence how much additional time bus occupies a stop after passenger movement are completed. Okay, next we look at the bus lane. Bus lane criteria or bus lane factor. A bus lane is a lane on roadway which bus operates. It may exclusive, which is provide or allocate for bus only to use that particular lane, or shared with other traffics. The vehicle capacity of a bus lane is mainly influenced by capacity of critical bus stop located along the lane. Typically the stop with the highest number volume of passengers, or could be the stop with insufficient number of loading area. Okay, the type also will influence the capacity of bus lane. So this is the typical type of bus lane design or bus lane area, bus lane type of the facilities. First one, bus lane have no adjacent lane. Second type, bus lanes have partial use of adjacent lane, which share with traffic. Bus lane provide for exclusive of two lane buses. We share this typical one. So this one they have two lane of the exclusive exclusive bus lane. Okay, this one they have also the bus lane exclusive but single lane. Sometimes they can also share lane with other traffic. Okay, when the lane is primarily for mixed traffics, there is no formal design of the bus lane either with the signing or pavement marking. Also, there is no dedicated to be colored if they're used for mixed or shared. The greater exclusivity of bus lane, the greater number of lanes available for bus to minibus, thus the greater bus lane capacities. It means if we can do exclusive bus lane, we can reach the capacity of the operation for bus lane services. Okay, bus lane capacity also influenced by skip stop operations. Okay, bus lane capacity can be increased by dispersing bus stop so that only a portion of buses use the bus lane stop at particular set of stop. This allows a faster trip and reduces the number of bus lane stop for each activity. So we can monitor, or we can do the exercise for skip stop operations. If we need to increase the headway or the capacity of or the level of service for particular buses for that particular route. Okay, platooning. When skip stop are used, gathering buses into platoon at beginning of skip stop section maximizes the efficiency of the system. So each platoon is assigned of a group of stop, and the platoon bus travel is trained past the skip stop section. Okay, the number of buses each platoon should ideally be equal number of loading area at each stop or each bus stop area. So we can also consider as a platooning. So they're going to move not synchronized, but we can assign a few number of the bus to be operate for that particular hour or particular schedule. Okay, bus stop locations. Fast side stop provide highest bus lane capacity. This is quite good practice, which is we can move a bus stop after intersection. But other factors such as conflict with other vehicles, okay, transfer opportunities and traffic signal timing must be considered when setting this bus stop, but this particular type. Okay, we move to this first exercise. I will explain how to calculate or to solve this particular exercise. After that, student can be proceed with this problem. I provided three problem student to be uh, do the practice. Okay, this first problem, this the second problem, and the last one is third problem. Okay, I will share the first one, how to uh, calculate or solve this particular exercise. Okay, it's about dwell time and failure rate, especially for bus stop, number of bus stop, according the dwell time in terms of the operation for this particular 20 bus stop locations. Okay, table 1 shows dwell times were observed at 20 bus stops located in a city center. Okay, determine coefficient of variations, which is CV. Later I will show you of dwell times and comment how large variation in dwell time affected bus loading area capacity. So given additional information, capacity of berth is considered as loading area. Is 8 buses per hour. K green time ratio is 0.3. Green time cycle, signal cycle 0.3, and clearance times is 8 seconds. So we don't have to calculate the dwell time, they given already when they doing the observation and they calculate already. So we just use this particular dwell time to calculate the coefficient variations and also the failure rates. Okay, these are the calculation that we're going to use. Okay, okay. What we need to do first, we have to determine the mean. The mean. After that, we can determine the standard deviation and we can obtain or determine the CV or coefficient of variation using this formula. Okay, for calculate the mean, first we have to uh, extension the x and deduct by means. So the mean is you can directly finding total of the dwell times, okay, divided by 20 as the bus stop numbers. Okay, we can obtain the mean value is 90.5 second. So for calculate this one, so we just deduct the value of each dwell time for the bus stop with the mean, then we square it. So don't worry about the minus, because you square, the value become positive. So we calculate all the value from this particular bus stop until the 20th. Okay, then we can determine first one for standard deviations. Before we need to have the standard deviations divided by means, then we can obtain the coefficient of variation. Okay, so the formula is square root summation of this value, mean individual summation of the individual dwell time minus mean. So we obtain this one value, 50,517. So divided by 20 minus 1 is the standard procedure for standard deviation formula. So we obtain 51.6 second. Then we can calculate straight away to determine coefficient of variations. So from here we obtain 0.57. So we just answer the question that asking for calculate the coefficient variation. Next, we want to determine the failure rate. Okay, the relationship between bus loading area capacity, which is BBB, okay, consider bus and coefficient dwell time, which is CV. Okay, we have this particular formula. So I have attached the exhibit to refer this formula and also the several chart or several tables. Okay, bus loading area capacity. So we have this formula. So G over C is ratio, green time. So here the additional explanation for each variable. KTC is clearance time between successive bus. KTD is average dwell times. Okay, Z is normal one-day normal variate corresponding probability wheel behind the bus stop estimate to failure rates. So now we have to determine this one. In this the formula, we have to determine this one, the failure rate. Okay, the CV coefficient ratio we have calculated. Okay, this one we have to calculate until we obtain this ZA value. So we have to solve this particular formula and determine the ZA. So now we obtain ZA is 1.995. So what should we do after that? So we move to exhibit. So you can refer this particular table, which is under failure rate section. Okay, probability Q buses will not behind the bus stop of failure rates can be derived from basic statistic, which is ZA. Represent under one tail or normal curve beyond acceptable levels of probability. So ZA is the series of statistic analysis. We can determine the failure of percent of our probability. Okay. The capacity under normal condition at 25% as failure rates. Okay, now we move to this value. We refer this value 1.955. Okay. It's somewhere here. It's somewhere here. Okay, if I highlighted this value, so now we have here 1, we have here 1. So why I cannot highlight that. Okay, but our value is 1995. But here value we have 1996. So 1195 is between this value. Okay, this one between this value. So we have to do the interpolations. So to get value of failure rates, we obtain the ZA value here, which is 1. I just write this one. We obtain the value here. 1.955. Okay. So we're going to determine here what is the failure rates for this particular value. Okay. From there, we can do the interpolation. Then we can having the value of 2.5 failure rates. It's quite if we get the value, we still can do the rounding value. So we can also having 2.5% failure rate. So which is very low. Okay, we can read this explanation. Large variation in bus stop dwell time is higher coefficient variation dwell times will result lower loading capacity. This means the loading area will be able to accommodate fewer buses than desired. So in our case, consider the failure rate to be good. If you read these particular suggestions, The CBD stock Z value of 1.44 to 1.04 should be used. They result as 7% to 15% respectively. That will be quite Q will be developed. But if we have a value of value ZA value of 1.9, 1.96 or lower, so it consider this value result Q beyond bus stop only 2.5%. So this is very good and acceptable. So this one is considered to be acceptable as well. But this one much more good. So in our case, the failure rate is considered very good. So the acceptable value here, they can consider 50%. But in terms of the capacity under normal condition, 20% still can be acceptable for under normal condition for capacity. So that's how we're going to obtain the result and to give some comment for our particular exercise for this question. I think that's all how to solve this particular problem regarding our question, this one. So for the next problem and calculation, okay, you can try, then we can discuss further. Okay, I think I will stop at this particular exercise. Okay, you can proceed to calculate that three exercise. This one, this first these three problem. The first one, the second one, and the third one. Okay, that's all for this session. We will continue for next session. Thank you.